Okay, check. All right, we're going to review. This is Sunday. We've been studying the law of sines. Okay, here's a triangle, ABC. Notice the little letters across, big A, angle A, and we know how we label the sides across from them. Little a, angle B, angle C, little c. The law of sines says the sine of angle A to its opposite side equals the sine of another angle in the triangle to its opposite side, like B, and sine of C to its opposite side, little c. Okay? These ratios are all equal. You can always flip it, be consistent, but you put notice little a is the sine of A equals little b to sine of big B, as little c is the sine of angle C, right? The angles are the capital letters, the sides opposite are the small, all right? The three cases where we use the law of sines is angle, side, angle, angle, side, angle. But this case, we have to get the third angle first. We have to have, here I've got A, B, C, these two angles on the side, I need to get angle B using 180 minus your two angles, the triangle sum theorem, okay? All right. We also have angle, angle, side, okay? Angle A, C, and this side would give me a known ratio. This is to this, and I can solve for, and I know this, okay? All right. If you have a chance, work your smaller angles first if possible, okay? And check that all angles add up to 180 when you're done. Because you might have an obtuse angle, and if you ever did inverse sine, it'll give you always an acute angle. And if it needed to be obtuse, you wouldn't add up to 180. So work the smaller angles first, and then you use the triangle sum theorem, you can get the third angle, if it's possible, okay? All right, here's a quick example of angle, side, angle. We're given 35 and 15, and I'm given the side here, but notice I don't have any complete ratio. Angle, no side. Side, no angle, no side. So we do 180 minus 35, and then I subtract 15. Or you can add these together and subtract them. 180 minus 50. But I find out that this third angle is 130. And now I've got all three angles. And now I have at least one. I've got 130 is to 5. I've got this known pair. So I can go sine of 130 is to 5. And I choose the sine of 35 is to x. Cross product, so 5 times sine of 35 equals x times sine of 130. Divide both sides by sine of 130, I solve for x. All right? Now we can do it again, and we still need to solve for y. Sine of here I chose sine of 130 again is to 5 equals sine of 15 is to y. Okay? Same basic cross product, 5 times sine of 15 equals y times sine of 130, and we divide both sides by sine of 130, and I get y. All right? So angle, side, angle, you have to get the third angle first, which is very easy. They add up to 180. Angle, angle, side, and notice we're solving for sides right now. That's fairly easy. No inverse sine, okay? All right. I'm given here a 40, 60, and a side of 4. Notice I changed up. This is TRS, okay? A triangle TRS. You can go ahead right away and figure out what this angle is. This is 100. This is going to be 80, okay? But right now, here's my known ratio, angle to side, okay? Sine of 40 is to 4. And let's go ahead, and I could solve for either one of these if I've already figured out that's 80. But we're given 60. So sine of 60 is to r, little r, okay? Same thing, cross product. R sine 40 equals 4 sine 60. We divide both sides by sine of 40, and I get r is 5.4. I've already figured this out. 180 minus 100, or minus 60 minus 40, that's 80. And we have one more cross product to do to solve for, I believe, little s. So again, sine of 40 is to 4. Here's a known ratio. Equals sine of 80. What's my 80-degree angle? Is to s. Okay? And cross product, you're always dividing by what's paired up with the variable. 4 sine of 80 equals s sine of 40. We divide both sides by sine of 40 and I get s. All right. Now for side-side angle. Given angle T is 40 and I've got two sides. Little t is 8 and r is 10. I always, guys, people weren't doing this and I really hit home hard about this. I always put my angle when I'm given a side-side angle. This is where I could have two different triangles. I always draw my picture with the base unknown, question mark, and the angle on the left. And I lay it, and that's t. So the side opposite is little t, and that's 8. The remaining side I put here. If the side opposite the angle, okay, is the smaller side, you can have two triangles, okay? All right? On side-side angle, if the side opposite the angle is smaller than the other side, and I always put the other side here, I leave the base unknown, okay? Then I can have two triangles. So here I label this T, opposite that is 8, and it says R is 10, I put that here. This can be swung around, and this could be the other triangle. This is the exact same, this right here is the exact same criteria for this triangle. Angle of 40, little t across from it's 8, and the remaining side I put here. I make the last side, it forms the angle. See that 10 and that 10. Okay? One's going to be the acute triangle, and the other will have an obtuse angle. Here's a case where, a side-side angle case where you're only going to have the one triangle. Notice, my angle's 40, the side opposite's 12, and the side next to it that forms it's 8. Notice this, when this side's the bigger side, it cannot be swung around. If this were repositioned, it would be way over here. And that's a totally different triangle. So whenever the opposite side's the bigger side, the side opposite the angle, you're good. It's one triangle. Okay. So here's your cases. Here we are again. First, this is something I didn't really cover, but let's see if it is a triangle. We want to go ahead. One thing I'm going to show you is figuring out the altitude from the vertex perpendicular to the base. I basically got a right triangle here. I can solve for this altitude and say, is it a triangle? This side has to be, this side that's labeled 8 needs to be at least as big as the altitude, or you'd have some type of situation like this where there's the altitude, and this side's not even big enough. It's really not even going to form a triangle, so it at least has to be as big as the altitude. Okay, so if I draw the altitude, this, like I said, this segment SR or little t needs to be at least as big as that. Okay, so let's figure out how big the altitude is. It's basically SOHCAHTOA, right? Opposite, notice I've got sine of 40 degrees. Okay? Opposite over hypotenuse equals sine of 40. Okay, notice I've got my opposite's the altitude, and there's 10. All right? If I multiply both sides by 10, I get 10 sine of 40 equals 6.43. That's my altitude, okay? So this is 6.43. Notice, this is bigger than the altitude, so we do have a triangle, okay? And again, it's smaller than 10, so it can be swung around and will be our two triangle situation, okay? Where we've got an acute one and an obtuse one. But I just solved for the altitude. So now, it's very easy, guys. It's going to be, if you notice a shortcut, it's going to be this hypotenuse times sine of that angle, okay? If I knew this angle, I could get the altitude that way. I could get 8 times sine of this angle, but it's just sine is opposite over hypotenuse and solving for the altitude, which is the opposite. All right, let's talk about what we did yesterday with the two triangles. The first one, oh, I'm sorry, let me continue with the altitude. Notice, if I gave you a triangle that was 40 degrees, had an opposite side of 5, and we still had that remaining side is 10. How I remember how I draw the triangles: angle, opposite side, remaining side, leave the base blank. Here's my altitude of 6.4. Notice if that side's 5, it's less than the altitude. No triangle. Okay? This would be a situation where you would say it's no triangle. Also, if you did inverse sine, you would get an error, or you would get an error for solving for this angle. Okay? All right? If you're taking the sine of a value greater than 1, sine greater than 1, you'll get an error, or inverse sine of that, okay? All right, so notice in this situation where the opposite side's 5, it's less than the altitude. It's going to be a big gap right here. It's not even big enough to swing over and even touch the base, okay? Finally, here's a triangle where I gave you a theta, let's say 40, and I gave you the two sides where what the side opposite was 4. Okay, the side opposite is 4, and the remaining side was 5. So I paired up my sides. I got an angle, opposite side, and this is and the remaining side is 5. I've got side angle. Notice when I solve for the altitude in this case, I got 4. It's the same as this. So basically, what is my triangle? It is the right triangle. Okay, and that's the one triangle. When your altitude equals that opposite side of theta, when these two numbers are the same, this is your triangle. It is the right triangle. When that side equals the altitude, you have one right triangle. Okay? Finally, let's recap what we did. I've got 11 minutes. All right? We worked the first case where I've got the acute triangle. We go ahead, we solve that. Now we're solving for what? Inverse sine. I'm sorry. We're solving here. I've got angle. I've got side angle. Okay, side angle. Sine of 40 is, I've got my known ratio is to 8. As sine of c is to 10. We're going to do inverse sine and get that angle. Okay. Once we get that angle, we can solve for b. And now solve for side lengths, okay? All right, so now we've got the first triangle. Remember, on the second triangle, it's going to be obtuse, where this number 8 swings around, and it's over here now. C2, remember, is just 181. For the triangle 2, C2 is 180 minus C1. So if that's 40, this would be 180 minus 40, 140. If this was 30, this is 180 minus 30, okay? And this would be 150, all right? So for your second triangle, all you have to remember is C1 from the first triangle. Your next triangle that you have, this angle is 180 minus this. C2, we'll call it C2 for the second triangle, 180 minus C1, okay? I immediately figure out 40 in this, and I figure out this third angle. We know both sides, and all we have to do is one cross product for little b, okay? All right, so that's kind of a review on if you have the two triangle situations. Solve for the first one, the acute triangle. Remember C1 on the second triangle that's obtuse. C2 is 180 minus C1. Figure out all three angles and to solve for a side. All right, 14 minutes. Good night. See you tomorrow, guys. Be ready to go.